Let's talk about which derivative, and first I want to look at prime notation, both in f and in y, then the d sub x notation that your textbook seems to be in love with, and then finally Leibniz notation. Although prime notation and Leibniz notation are the two primary notations that we're going to see. So we're very comfortable with these by now. We've seen them a lot. If we see f prime of x or t or whatever, or y prime, we're talking about the first derivative. D sub x of y was the first derivative in d sub x notation, and dy dx was the first derivative for Leibniz notation. And we can see that for the second derivative, it's pretty intuitive, it's double prime, that notation sticks for us. We have the same going on in prime notation as we do in Leibniz notation. And it turns out that the only notation that departs from this trend is prime notation. Starting with the fifth derivative, it drops the primes and it puts a superscript number with parentheses around it. So when you see a superscript number with parentheses around it, that's the derivative. We don't put 5 tick marks or 6 tick marks or apostrophes or whatever. At the fifth derivative, we drop the prime and we pick up the superscript number and put parentheses around it. And that stays true all the way through the nth derivative. You will need to be very familiar with using prime notation and with Leibniz notation. All right, let's do an example of higher order derivatives or finding the nth derivative of a function. Many functions will cycle to a successive derivative of 0. Mainly that's going to be polynomial functions. And if you'll think about it and come up with an example, keep taking the next derivative, the next derivative, and the next derivative, and you'll get down to a derivative of 0. Many trig functions cycle to the nth derivative and never attain a value of 0. And this is not only true for trig functions, but we're going to see it's true for exponential functions, it's true for rational expressions. Frankly, about the only type of function that will go ahead and differentiate to 0 is going to be a polynomial function. So let's look at what happens here to a parent function of y equals the sine of 2x. So this is a composed function. 2x has been put into the sine function machine. So in order to find the first derivative, that's going to require the chain rule. And let's verbalize ourselves through the chain rule. It is the derivative of the outside, there it is right there, not changing the inside, times the derivative of what's inside. So that's why the derivative of sine of 2x is 2 times the cosine of 2x. Now we want the second derivative of y, which is going to be taking the derivative of the first derivative. And again, we're going to use the chain rule one more time. It is the derivative of the outside, which the derivative of cosine is negative sine, so you can see those two pieces there, not changing the inside, times the derivative of what's inside. Well, we've already got a 2 there, so we had to multiply that by 2 again. And so you can see that we're never going to differentiate to 0. Every step that we take, we're just iterating back and forth between positive and or negative sines and cosines. So many functions will not differentiate down to 0. One last thing that I want to cover, and we'll just cover it quickly because I have seen this before on some AP exams, and it's not like overtly given to you in your textbook. So it's something that I want to make sure that you know. What velocity tells us about an object or a particle in motion? An object will be moving left when its velocity is negative. So if it says for what values is the particle or the object moving to the left, you're going to take your velocity function and you're going to find the values when velocity is negative. Okay? For what values is it moving to the right? That's where velocity is positive. And for what values will the object be either at rest or changing direction? Now, at rest means we could be moving to the left, we could stop, which will give us a velocity of 0, and then we could continue moving to the left. So that's why we say at rest or changing direction. All right, and those are the three things that you need to know, and I just need those in between your ears where you can automatically bring those up to answer those types of questions. So this finishes this video. Come to class next time ready to do some homework problems.